In this lesson, what we're talking about is something called L'Hopital's rule. And L'Hopital's rule is named after a French mathematician, L'Hopital. Well, what's going to happen with L'Hopital's rule is a little bit different than whenever we're traditionally taking limits using direct evaluation. So we're only going to use L'Hopital's rule to find the limit whenever direct evaluation results in an indeterminate form, such as 0 divided by 0 or infinity divided by infinity. Also, it's going to be helpful if you have knowledge of what a derivative is before you learn this lesson. So some of the stuff is going to look kind of magical unless you have practiced a little bit taking derivatives. So if you haven't taken derivatives yet, practice those and then maybe come back to this lesson. So here in a nutshell is what an example of L'Hopital is going to look like in arbitrary sense. So we have limit as x approaches c for f of x divided by g of x. And so if I plug in c using direct evaluation, I would get f of c over g of c, and maybe I end up with an indeterminate form 0 divided by 0. Well, L'Hopital's rule says take the derivative of the function that's in the numerator and take the derivative of the function that's in the denominator. So f of x becomes f prime, g of x becomes g prime. So if that's the case, then I use direct evaluation again. So I'd look at f prime of c divided by g prime of c, and hopefully that's going to give me my limit L. And I know that's a very, very arbitrary set of functions that we're using, and it probably doesn't make a whole lot of sense unless you see it a more concrete example. So let's look at something like this. If I were to take the limit as x approaches 0 for 1 minus e to the x divided by sine x, if I plug in 0 using direct evaluation, I get 1 minus e to the 0. So 1 minus e to the 0 divided by sine of 0. I know e to the 0 is 1, so this is 1 minus 1, which is 0, divided by 0. And that's what we call an indeterminate form. So direct evaluation would not work in order to find my derivative, or excuse me, my limit. So what I want to do is I want to use L'Hopital's rule, which means I'm going to take the derivative of what's in the numerator and what's in the denominator. So what this is going to give me the limit as x approaches 0. Instead of 1 minus e to the x, I'm taking the derivative of that. So I can maybe use this kind of crude notation, 1 minus e to the x. This gives me negative e to the x in the numerator. In the denominator, I know that the derivative of sine is cosine x. So if I look now at the limit as x approaches 0, I could reevaluate, and this is going to give me negative e to the 0 power divided by cosine of 0. So this is going to give me negative 1 divided by positive 1, which is negative 1. So in this case, I can find my limit using L'Hopital's rule. So I just took the derivative of the numerator, and I took the derivative of the denominator to get negative e to the x divided by cosine x, plug in 0 using direct evaluation, and I get the result negative 1. So the limit here as x approaches 0 is negative 1. Say I take something like x squared minus 1 over e to the x, and I use the limit as x approaches infinity. So I'm determining the end behavior of this graph. Well, there's a couple things you could do. First, you could notice that if you have a quadratic like x squared minus 1, the amount of pull it has on the function is much less than something exponential like e to the x. So I know just from knowledge of graphs that this limit is going to converge to 0 as x goes to infinity. But maybe you're in a bind and you just kind of forget the rules that are going on. Use L'Hopital's rule. So take the derivative of the numerator, so this is limit as x goes to infinity for 2x divided by e to the x. So derivative of x squared minus 1 is 2x, derivative of e to the x is e to the x. If I plug in infinity, I still get infinity divided by infinity, which is indeterminate. So I'm going to do this one more time. So I look at the limit as x goes to infinity. The derivative of 2x is 2, and then I have e to the x in the denominator. And in this case, I'm going to end up with something really small over something really large. So if I were to, in a sense, plug in infinity, I would get 2 divided by e to the infinity, which is 2 over infinity, which is 0. So what I know here by L'Hopital's rule is that the limit as x approaches infinity for x squared minus 1 divided by e to the x is going to converge to 0. So L'Hopital's rule is really nice whenever you encounter indeterminate forms. You can simply take the derivative of the numerator, take the derivative of the denominator, and you're going to end up with a very nice way of finding limits without having to factor or conjugate or use other properties.